Welcome to the introduction. This is where you're going to get a chance to meet Network Monitor. In this lesson, I'll cover just an introduction as to what Network Monitor is and what it can do for you. Then we're going to get into installing Network Monitor and running Network Monitor. Now, there's some special groups involved when it comes to running Network Monitor. Not just any user can do this in your environment. So I do want to make sure you understand how to install it properly and how to run it. Then you're going to meet the interface, and you'll see all the panes that we have that you can get information on. Also, how to close those panes down and then get back to that default view. I don't know how many times I've closed panes down so I could see more information on the screen, only to wish I hadn't closed panes down, and it's nice to get that default settings panes back in just one click of the mouse. Then I'll show you how to capture data and save data. Now, what Network Monitor can do for you is it allows you to capture packets, data packets that are on the network wire. You can then take a look or analyze that data or even the traffic patterns of the data. Now, most people think you have to be a Network Monitor expert or at least an expert in protocols or even the network application you're trying to troubleshoot. But I'm here to tell you, you do not need to be an expert. I have tons of tips and tricks you're going to see throughout these lessons that'll help you to be able to use Network Monitor without having to learn different protocols or application behaviors. Now, there are some various scenarios when you might want to use Network Monitor, or as I like to call it, Netmon. Some of those scenarios would be possibly someone trying to connect and download email and they can't, or access a SQL database across the network. Whatever the issue is that you're trying to troubleshoot with Network Monitor, the only real requirement is that there's network traffic generated for you to look through. The history of Netmon. In the past, whenever we got new versions of the operating system, server versions of the operating system, there was a version already built in, and that was called the light version. But we haven't had the light version integrated in the operating system for quite some time now. Now, in the past, there were two different versions. You could get the light version right there in the OS, or you could get the full version if you had SMS. Now, we can download the full version, which includes a promiscuous mode. Promiscuous mode simply means you can capture data packets on the network, any data packets. In the past, with the light version, whatever machine you were running Network Monitor on, you could capture the data packets that were either sourced from that machine or destined to that machine, but not additional traffic between other machines. With the promiscuous sniffers, you can get all the traffic. Now, there's also another Network Monitor type or network sniffing product out there called Wireshark. In this lesson, we're only covering Netmon. You can get Network Monitor as a free download from Microsoft. You're not going to get it in the operating system any longer. It is supported to run on Windows XP and pretty much any later desktop OS, Server 2003, and any later server operating system. To install Network Monitor, you've got two versions based on the architecture of the operating system you're going to install it on. You've either got a 32-bit version, the x86, or a 64-bit version, x64. Make sure when you do download Network Monitor, you get the right version. What it will look like is nm34_x64.exe for the 64-bit version, or nm34_x86.exe for your 32-bit version. Let's take a look at actually downloading and installing Netmon. I've opened Internet Explorer and just Googled, or if you prefer to do a Bing search, you can do that as well, Network Monitor 3.4. The first or second hit will be the hit that will take you right to the Microsoft site to download. Scroll on down and take a look at these guys. You'll see that what I have is 64-bit flavor, 32-bit flavor, and if you want to put it on an Itanium machine, they've got one for that as well. Notice they're really small, not a lot to it, so just go ahead and download whichever version it is you would like to install on your machines. I've already downloaded the 64-bit version because I'm installing it on a server, My server is Server 2008 R2 SP1. And, well, we know since Server 2008 there is no 32-bit server operating system any longer. So I've already downloaded the 64-bit Netmon executable. This is my virtual machine that is running Server 2008 R2 SP1. And as you can see, I've got the Netmon 34_64-bit all ready to go. In order to install, just go ahead and double click on that guy. It will tell you that this will install Microsoft Network Monitor, the capture and parser engine, followed by the Network Monitor parsers. And do you want to continue? So it's going to do a couple of installations. We'll say yes. This really is, it's so small, it's very quick to install. Doesn't take up a lot of space either. On the Welcome to the Microsoft Network Monitor 3.4 Setup Wizard, click Next. On the End User License Agreement, we have to accept the terms. Click Next. And then, do you want to use the Microsoft Update to help keep your computer secure and up to date? I'm going to choose at this time not to use the Microsoft Update. Click Next. And I'm going to do a complete installation. I do want a shortcut created on my desktop. It's always nice to have one right on the desktop. If you're installing it, you probably are going to be using it pretty soon. So I like to put it in a place that's easy to get to. We'll click Install and let it rip. When setup has completed, click Finish. Then we have our second installation, which is the parsers that are going to be installed. The parsers are the piece of programmatic code that can actually interpret the data on the wire and turn it into readable text for us humans. So the parsers are pretty important to install. I don't think you'd get very far if you chose to install Network Monitor and not install the parsers. I don't even think there's a way for you to do that, so you might as well just allow it to run through both installations. When the installation finishes, that screen just disappears and you will now have a new icon on your desktop, Microsoft Network Monitor version 3.4. Now, not just any user can run Netmon. I mentioned this earlier, but I want to go into a little bit more detail. It's a little different on Windows XP as it is on Vista and Windows 7 and Server 2008 and R2. On XP, anyone who's logged on as a local administrator can run Network Monitor. But on later operating systems, you could log on as an administrator, then you would need to run Netmon from an elevated command prompt, or you could always right-click and choose Run as Administrator. Any non-administrators who attempt to run Netmon, they're going to get an error message. When they try to capture data, they'll get an error of none of the network adapters are bound to the Netmon driver. And when you're viewing your network adapters inside Netmon, you'll see the error. This network adapter is not configured to capture. To set up a standard user to allow them to run Netmon, you would have to add that user account to the new Netmon users group. Now that group doesn't even exist until after you've installed Netmon. Then you could log on as that standard user who has been added to the Netmon users group and run Netmon just like an administrator. This is what Netmon and your networks is going to look like. Not a lot of panes here. If you notice, the tab that I'm on, first of all, is the Start page. On the Start page, I could choose to create a new capture, or I could open a file that was previously captured. In the bottom left corner is where you're going to find your networks or your network adapters. Notice I have 4 listed there. I have a Microsoft ISATAP driver. I have an Intel Pro, that's my wired driver. I have a Teredo tunneling and a WAN mini port. Now notice I have check marks in 2 of the 4 boxes, so you can choose to capture data on one interface or multiple interfaces at the same time. Now you'd need to scroll over to the right-hand side to see that the state of that network adapter is actually bound, which means it's bound to the Netmon driver, and it could therefore capture data. Before you use Network Monitor, you might want to consider how much disk space is going to be required. So you're going to have some capture files that are created. They'll be named cap temps, and they'll be created in your local settings temp directory. Now the files can grow to be 20 megs each as long as you continue capturing data until you're within 2% of available free space before it automatically stops capturing. For memory and processor utilization, you'll have Enable Conversations box selected by default. It uses a lot more memory and processor cycles, so you might want to disable conversations. That's more of an advanced step. I don't like to disable anything until I've gotten used to using a product. Then you can tell from your own experiences what you want to leave enabled and disabled. If you'd like to change the settings for the captured files that are created, we'll go to the Tools menu, Options, and Capture. Notice the size is 20 megs. The default folder location to store them. Stop capturing when free disk space is less than, and the default setting of 2% is in there, which you can change if you'd like. You could also select to capture only the first X bytes of a frame. I have never ever used this. I'm always afraid that I'm not going to get the one piece of data that could really help me troubleshoot an issue, so I always capture entire frames. You can set it up for a record capture filter, record active network adapters. Conversations I mentioned are enabled by default, and also with this version of Network Monitor you can show the processes in the network conversations tree that actually spawned the data packets, which comes in really, really helpful. Let's get our first look at Netmon. Back on my server, which is a domain controller, we'll double-click Network Monitor. Open that up, and the first thing it asks, do you want to use Microsoft Update to help keep Network Monitor secure and up to date? I do not want to. So I'm going to remove the periodically check for updates when Netmon starts and choose no. We'll maximize that screen and notice what we have here. There's our new capture tab, capture file. If I scroll over here, I can see that my state is bound for every single user. Now this is because I'm logged on as an administrator. It is a domain administrator, but you have to be an administrator or a local administrator in order to get the state bound. Otherwise, the Netmon driver is not able to bind to your network interfaces. To start a capture, there's a couple different ways you could do it. On the Start page, you could choose to create a new capture tab. Or you can go through the menu, File menu, New, Capture, choose your network from the selected networks window, or on the capture menu you can click Start or F10 for the hotkey. What gets captured? Anything that is on the network wire if you're in promiscuous mode. Let me show you what that looks like. Back on our server, if you look at the selected networks, we can go down to P mode. The P mode button is a toggle switch, so if you click it once, it enables it, and if you click it again, it disables it. So how do you know if it's actually in promiscuous mode or not? I like to open the properties, and then I can see if P mode is enabled or not. So I'm going to go ahead and leave it set to promiscuous mode, which remember means it's going to capture all network traffic. Once you have captured traffic, this is what your user interface is going to look like when you're actually looking at the data. This is where our network conversations will be, our display filter, and there's actually a few windows underneath this guy. We're going to see those when we get into our first capture. There's the frame summary. Each line here represents one packet of data. When you highlight a packet of data, you'll get the frame details, and the same details you've highlighted in the frame details will be in the hex details pane. This will make a lot more sense after we've captured a little bit of data, and you can come in and play around with what you're looking at. This is what it looks like when you have some data that's been captured. And what's nice about this version, and the past couple of versions, actually 3.x versions, it all showed you data packet captures in real time. In the past, with the older versions of Network Monitor, it was kind of like shooting in the dark. You turned it on, you waited until you thought you probably had captured an error condition, and then you turned it off blindly, opened the capture, and then could go through and look at the various frames of data to find out where your problems were. With this, you can actually see them as they come in. Notice On the network conversations, you can see that this is my traffic. So this is either data packets that are destined to my server or they originated on my server. So that's my traffic. And notice what we're looking at here are actually processes. This is the service host, DNS, local authority subsystem, more on service host. And then there's other traffic because I was running in promiscuous mode as well. And these are what the frames look like. I mentioned one frame on each line. Let's capture some data. To capture data, I'm going to choose New Capture and click Start. Now, in a real-world environment, you're going to get a lot of data really, really fast, especially running in promiscuous mode. In this situation, I've got two domain controllers running. So notice there's quite a bit of conversation happening between these two machines, even though we don't have anything connected to each other. So if I scroll down, notice I'm already up to 46 packets, and I haven't done anything yet. Do not be surprised or scared when you do your first data packet analysis and you have over 120,000 packets within a matter of seconds. That's to be expected. I'm going to show you later on some really awesome tips and tricks that I have used in a lot of large environments so that I could pinpoint exactly where the data is that I'm looking for it. I'm going to stop this capture. We've got some data we can actually look at here. And notice what I have. Under Network Conversations, I have a conversation of Local Security Authority Subsystem, good old LSAS. If you highlight LSAS, then you should see the conversation between these two IP addresses. Now, the machine I'm currently on is IP address 10.10.10.50. My second DC is the 10.10.10.51. And what's nice about seeing this is if you had multiple domain controllers, you would have LSAS conversations with each one of them, but then beneath that it would list by IP address, this is the conversation between these two machines. And then you would have multiple conversations listed based on how many DCs you had and who was talking to who at that time. Now, I did mention that allowing network conversations to be enabled by default does take up a little bit more processor time, and really all it is just filters that are created for you so you don't have to create your own filters. And we're going to get to filters a little bit later on. So I just wanted to mention network conversations to start with. On the display filter screen, this is where you could apply a filter if you wanted to capture only specific data. And I highly recommend not ever doing this because you could accidentally exclude packets of data that could have helped you in a troubleshooting scenario because you didn't know exactly what you were looking for yet. I can't tell you how many times I've been surprised at what I found the actual issue to be based on what the symptoms were. So I don't ever use a display filter. It's a very rare, I think in the 20 years I've used Netmon, I might have used a display filter twice. If we look at the information in the frame summary, notice the column headings. You can take these and squeeze them down a little bit. This would be the frame number. The first frame that was captured was frame number 1. Let's look at all traffic first of all, because we're starting on frame number 4, and I know that's not right. So we have frame 1, 2, 3, 4, 5, and they should be sequential. If you looked at a data trace and you started with frame 1694, you have a problem. So you're missing everything prior to that. Then you'll get the date and time of when the packet was captured. The time offset is how long Network Monitor was running before that packet was actually captured, which just looking at these sometimes can help you see that, wait a second, why is it taking so long to get a response from that default gateway or that domain controller? So sometimes just looking at the time offset, if it took a few milliseconds to actually get that data packet, you might have an issue of bandwidth. Here's your process name. This is the machine that your data packets, the IP address of the machine where the data packets originated, that's under the source. The destination is who they're destined for. The protocol name that created them. Here's a nice description of your data packets, which comes in helpful. We can see these are TCP packets. This is actually TCP acknowledged, ACSIN, and acknowledged. So these three packets are setting up a TCP connection with our second domain controller. And then we have our conversation ID over on the right-hand side. Let's take a look at just one TCP packet. So if I highlight the TCP packet, and then in the frame details, by the way, you can just rearrange these so you can see a little bit more information if you'd like to. You can come down here and find out. Have you ever heard someone talk about the header information on a packet? Well, the information starts here. The type of network is an Ethernet, and it's an IPv4. Destination address, there's the MAC. Source address, MAC for that guy. So if we highlight that, I could go down to the destination address. And as you can see, highlighting the destination address highlights the MAC address in hex, which is what MAC addresses are in the hex details pane. But the point here is to be able to highlight a data packet to look at the actual information inside that packet. Here's the source address. Highlight the source address and you can see the MAC address over in hex as well. You can see the version of IP, the header length, typical 20 bytes of data. Time to live. This packet gets 128 as its time to live. What does that actually mean? It means that every time a data packet crosses a router, the time to live is decremented by at least 1. And if it takes a while for that router to process the packets across it, then your time to live, or TTL, could be decremented multiple times based on how congested that router is. So the TTL just gives us a nice way of saying, you know what, if you haven't reached your destination in 128 hops, you should probably drop off the network and leave it available for other traffic that can find its destination. So think about the internet for a second. What about searches that people have created? What if those data packets just ricocheted all over the place until the end of eternity? At some point, it would be so bogged down and saturated with data we could never do anything with it. So this is one nice, easy way that data just kind of dies after it's done with its TTL. That data packet is just dropped. Now, I know there's a lot more on this screen, but for now, I just wanted to get you kind of started and show you how to take a trace, get some captured data, and make a little bit of sense out of that data. You can save the captured frames, and your default location is going to be in your Documents Network Monitor 3 Captures folder. You can choose File, Save As, and then you can choose to save all the captured frames, just the displayed frames if you've already filtered them and told the filter, oh, just show me the TCP packets, I don't want to see anything else. All those LSAS packets would go away. So you could do a File, Save As and just save the displayed frames. You can also choose to save the selected frames or do a frame range. And notice the range I have listed in here. I'm telling it to save frames 1, 3, and then 5 through 12. Once you make your choice, click Save. This is what saving captured data looks like. Back on the server, we can click Save As, and on this screen, this is where we can tell it the frame selection. All captured frames just displayed or selected or specific range. We can give it our capture name. I'm just going to name it Test1 and choose Save. In some of the older versions, the default setting was to save displayed frames only. And that was horrible, because what would happen if you spent days researching and looking at what data is actually inside this capture, and now you've got it filtered down so you can poke and dig around. Somebody walks in the room and says, hey, it's time to go to lunch, let's all go, we're heading out the door. You're like, oh, okay, you do a File, Save As, and all the rest of the data goes away. All you see is what you had filtered out. So I do like that in this version, your default setting was to save all frames, not just what was being displayed at that time. You can always create your filters later on, but you can't get that data back. If you've saved it and did not save all data, There's no way to get that back without doing another trace. So saving your captured data gives you a chance to come back and look at it again later tonight, the next day, maybe even next week. And one thing that you're going to see as we get into network monitor in a lot more detail, sometimes I like to save captured data of working environments, so I have something to compare my broken captures to later on. What we covered in this lesson is an introduction. You got your feet wet with Network Monitor. You've at least seen the product now. You know that there are multiple versions based on architecture of your machine or operating system that's installed. And we talked a little bit about the fact that not just any standard user is allowed to run Network Monitor in your environment. In fact, in some environments, it's a fireable offense to actually run Network Monitor. So you do need to be sure that you're not going to get in any trouble for running Network Monitor. And you also want to be sure that you don't put your captures when you save them on something that could get lost, like a USB stick. Maybe you drop off a shirt at the dry cleaners and there goes your trace. There's a lot of information and could be sensitive information inside these captures. This is the actual data from your network, so please be careful with these. You met the interface. Well, you met about 25% of the interface so far. I'm going to save something for later because there's a lot of really cool things we can do with the interface, but we need to have some good data to play with first. The last thing we covered was capturing and saving your data so that you can come back and take a look at it later on. One of the reasons why you might want to do that is to have a working capture. Everything worked great in this one. Now you've got a machine that's not working great. You need something to compare it so you can figure out where it's broken. Saving the data is the best way to do that.